Hello, in this video we're going to be reviewing reactions of alcohols doing specific examples. So we're going to pick one molecule and then we're going to go over a series of reactions and see the transformations. So let's get started with the following. Let's say, here I go. I'm going to give you this molecule to start with. In here I have my OH on the wedge, and here I have an ethyl group. That is on a dash. Okay, so here we see this is a secondary alcohol. And in the problem, what it says is to give the final product after a series of reactions. So I'm going to copy here what is the series of reactions that I presented, and we're going to be walking this through each one of them. So the first thing it says is HBr, and it also says in parentheses, this is the problem I picked. So that is an SN2. Then it says that you treat it with sodium hydroxide and heat. Condition number 3 says that you're doing hydroboration, so boring in THF, followed by, let's say A, by the oxidation reaction. So hydroboration, oxidation. Here we are. So what we're doing here to do this type of problem is go through each of the reactions. So it says now that this is an HBr nucleophilic substitution. So remember that if we're doing an SN2 reaction, we are going to be having an inversion configuration at the center that has the OH. But why do we have HBr? So HBr, because this is a bad leaving group. So when we have, say, HBr or any acid, we're going to be protonating the OH. In that form, we are going to have a much better leaving group. Now, this is a good leaving group, and we have here this, the protonated alcohol. Next, it says that this is an SN2 reaction, so your nucleophile is going to be bromide. And because it is an SN2 pathway, you're going to have an inversion of configuration. So now I am going to write this, so bromine is going to be on dash, and this is going to be on dash as well. Now, let's consider the second reaction. Second reaction says NaOH and heat. So this is a secondary alcohol. Under those conditions, it will undergo an elimination reaction. So let's pick another color here. So this is reaction 2. Now notice that I have bromide on the dash, but I have here a hydrogen. Of course, I have hydrogens on the other side, but here when you do the alkene, it's going to be more substituted. But the bromide and the hydrogen are opposite side, and this elimination happens through an anti. The mechanism is anti. So the beta hydrogen in the bromine, they are opposite sides. So here what is going to happen is that you're going to have, say, OH, getting this hydrogen, and then that arrow is pointing, it's bad, and then we're going to form a double bond, and this is going to go. Now you're going to be forming, then your product is an alkene. So the product of reaction 2 is this alkene. Now, because this is an SN2 carbon, now we don't need to be drawing wedges or dashes. So is that alkene? The final reaction, so reaction number 3, where the number 1 was, say again, it was the substitution, but first you transformed the OH into a good leaving group and you did the nucleophilic attack. Second reaction is the elimination reaction, and that is an E2. And now we're going to go and see the other condition. This is hydroboration oxidation. What this is doing is an anti-Markovnikov hydration. So let's do number 3. Number 3 here, again, as we said, is anti-Markovnikov hydration. And because it's anti-Markovnikov, let's remember that now in the anti-Markovnikov, you're going to have the H at the more substituted and the OH at the least substituted. But also, this reaction happens through a scene mechanism. If you need to review this, I have more videos about these reactions. Here, what we're doing is analyzing what is the product of each of these reactions. So anti means you're going to get them, the H here at the more substituted and the OH here, but the H and the OH need to be on the same side because this reaction happens in a scene fashion. So say if I am doing OH here, I need to have the H also on a wedge, which means that the ethyl would be on a dash. Again, this is the form in which you will see it, which means the AH is here. But also we will have the enantiomer to that. So in which you will have, so let's remove the H again. We know it's there and we know this is a right product because we need to have the H and OH on the same side. But also notice if the H is on wedge, the ethyl needs to be on dash. So now this is one of the products, I'm erasing, that's the way you would see it drawn. So I'm trying to make it describe. So the final product, this is 1. The enantiomer to that, let's throw it in smaller here. This will be on the dash, then your hydrogen will be also on dash, which means the ethyl is on wedge. So these are the products. So the final answer to this question after all the sequence is these mix of alcohols.